Welcome back, students. So when it comes to chemistry of phenolic compounds, acidity of phenols, Reimer-Timer reaction and qualitative test for phenols, these are few important topics. I hope you might have gone through my previous video where I explained the mechanism involved in Reimer-Timer reaction. If not, the link is given in the description. You can watch it at your convenient time. Now in this video, I'll be explaining about some of the important qualitative tests for phenols. Again, another important topic for the examination point of view. So stay with me till the end of the video, and now let's jump into the topic. Phenolic compounds can be identified by performing some of the preliminary tests, solubility test and also confirmatory tests. So each and every phenolic substance will be having its own physical properties. As a model, two compounds information is provided here. One is for as such phenol and the other compound is beta-naphthol. Phenol, it usually occurs as colorless liquid with phenolic odor. When it comes to beta-naphthol is a solid which is having pale pink color and it is also having phenolic odor. Now coming to the solubility profile, phenol is water soluble in nature and it turns blue litmus to red. Whilst beta-naphthol, it is water insoluble in nature because it consists of naphthalene ring system where the total number of carbons are 10. So once the carbon number becomes 5, then the borderline solubility achieves. It is because of that reason, in spite of having polar hydroxyl group, beta-naphthol, due to the presence of more number of carbons and the bicyclic system, it is water insoluble in nature. But because it is acidic compound, it turns blue litmus to red. Both phenol and beta-naphthol, they are soluble in 5% sodium hydroxide. Now, when it is tested with sodium bicarbonate, that is a sample containing phenol or beta-naphthol, when it is added to 5% sodium bicarbonate solution, there will not be any effervescence. This indicates that the compound is acidic, but it is not carboxylic acid and it is phenolic nature. And that is how the phenolic nature can be first identified based on a combination of litmus and sodium bicarbonate tests. So once the given compound is identified as phenolic substance, that is it may be phenol, alpha-naphthol, beta-naphthol, cresol and so on, then in the next step, confirmatory tests will be done. So these are the confirmatory tests for phenols. The first confirmatory test is known as bromine water test. So this bromine water test will be positive both for phenols as well as beta-naphthol. So when a sample containing phenolic substance is added to bromine water, then there will be formation of white precipitate. It is because of the formation of tribromophenolic derivative. So this tribromophenolic derivative is white in color. So this confirms the presence of phenolic compound in the given sample. Now the other two tests are meant for the beta-naphthol. So the second test is known as Lieberman nitroso test, where the sample is added with sodium nitrate crystals and drops of sulfuric acid will be added. And then immediately this test tube is heated for few seconds. So if there is formation of black precipitate, then that indicates the presence of beta-naphthol in the given sample. Even the presence of beta-naphthol can be confirmed by performing neutral ferric chloride test. In this, the sample solution is allowed to react with neutral ferric chloride solution in a test tube. So if there is formation of green to white precipitate instantly, that indicates that the given compound is beta-naphthol. So thus the presence of beta-naphthol can be identified and confirmed by performing Lieberman nitroso test and neutral ferric chloride test. So these are some of the qualitative tests for the phenols. I hope you might have understood the qualitative test for phenols. If this video is useful to you, then give it a like, subscribe my channel so that you won't miss my next coming important chemistry concepts. Thanks for watching and stay tuned to my next videos.